All right. Hey, everyone. Welcome to those joining us in person and those online. We'll get started in just a few moments here. For those in the room, feel free to, grab some donuts, some coffee, and we'll get started here in just a minute. Right. Well, as people are continuing to grab some donuts and refreshments there and joining us on Zoom, I'll welcome everyone to our first Data and Donuts session for the spring semester of 2025. My name is Alex Martin. I'm the GIS and Geospatial Data Coordinator here with the UT Libraries, and I'm also working with the UT Open Source Program Office. And so together, bringing you open source GIS from QGIS to Python. So before we get into the content here, I'll run by just some background about Data and Donuts and workshop logistics, and then we'll get into the content. So today's workshop will be conducted both in person. Here we are in the data lab within the Scholars Lab at the PCL here on campus. And then we're also joined by some folks on Zoom, and this is being recorded. And with that, there's also an automated transcription. As you may guess, it's likely not to be perfect, so just keep that in mind. For those in the room, feel free to interrupt and ask a question as I'm going along with the workshop. For those on Zoom, feel free to leave a question in the chat, and I'll get to it in due time. And yeah, we'll go here until about 1 p.m. and then try to leave 15 minutes for questions, and then we will wrap by 1:15. As I mentioned, that this is the first session of the Data and Donuts programming we have for spring 2025. You can see the dates and the other sessions we have planned for this semester. And for the first time, we have a series of programming happening during I Love Data Week, which is the week of February 14th. So you can see for 4 days in a row during that week, there will be programming each one of those days. And then we have another freestanding Data and Donuts on February 28th. There's a lot of really nice range of data research focused workshops. So feel free to check those out. You can go to the Data and Donuts library guide to register to either attend on Zoom or in person for those. And for those of you attending on Zoom who are unfamiliar with Data and Donuts, we do follow through with the donuts part of the brand, and they are available here in the Data Lab and the Scholars Lab. So I encourage you, if that is of interest, to attend in person in the future. And as I go through, keep in mind that this recording, as well as the slides and also the Python code that I write today will all be available online afterwards. So if you missed something or something's unclear, know that that recording will be available and you can access the content in terms of the slides and the code later on. All right, so we'll get into some things here. As I mentioned, this is partially brought to you by the UT Austin Open Source Program Office, which has been around for about a year and a half officially now in terms of a functioning office at UT. And our mission is to support the UT community across what we call the open source participation pathway, where, today, we're just kind of focused on using and introducing some open source software. But the really cool thing about using open source software is when you start to use it and familiarize yourself with it, you have the opportunity to then actually contribute to the code, make additions, correct bugs, and build collaborators and work on reproducibility. So, if this is of interest, or you're somewhere along this participation pathway, the UT Open Source Program Office is here for you. From individual consultations, we have a list of best practices for producing open source software and contributing to open source software. And we put on events like today. So go ahead and you can visit our website for more information, UT Open Source Program Office. And so for people who are new to the idea of open source software, or maybe you've heard the word, but why is there an office, and why are we kind of focusing on it in the context of GIS? Well, open source software is really important, especially in the research context, because it really promotes and helps reproducibility of your work. Because if things are open source, you can go under the hood and see everything that's going on with the software that you're using within your methodologies. There's nothing hidden, and a wide range of other researchers, collaborators, readers can see exactly what you did and reproduce your methods. So in that context, open source software is really an important part of the scientific process, because it helps with reproducibility. Also, as a researcher, you have full control over your methods, right? So you can go under the hood, you can see everything that's happening from the software perspective of your methods, and you don't have to worry about a proprietary company, making changes to the tools that you use without you being able to see what those changes are, or discontinuing something that you need, and maybe that's a few years after you did your work and published your methods. Well, now that's not reproducible anymore. But with open source software, that doesn't happen. So that's why we're focusing on that today, and also the Open Source Program Office is here to really support researchers who want to use and contribute and participate in open source software in a research environment. All right, so this workshop today, we are going to focus on a few things here. So introducing the fundamental knowledge required to work with GIS and geospatial data. So I would imagine a lot of people attending this are totally new to GIS, and that's great. We're going to focus on a pretty base level GIS workflow. So hopefully that will connect with people. And I'll go over kind of the real basics of GIS that are important to just start working with geospatial data. And like I mentioned, this is going to be focused on open source GIS software. I'll get to that in a bit. And then what I also am going to do today is demonstrate two different ways to work with GIS data in open source environments. So that one is with a user interface based software, which is kind of a, right, you open it on your desktop, point and click on tools. And then the other is a scripted environment. So Python, where you write code to do the work. So I will parallel the same workflow in both of those softwares. So if you're not new to GIS and are familiar with kind of the basic workflow I'm going over, but maybe new to Python, hopefully this will encourage you to start to think about doing some of your work in a scripted environment. To start at the basics of what is GIS, and I'd imagine most everyone has at least somewhat of an idea that came to this workshop today. But I think it's helpful to just kind of take a step back and define it. So geographic, that's pretty easy, right? It relates to a specific location on the Earth's surface. Usually we're thinking about coordinates, so like latitude and longitude, that allow us to place ourselves on the Earth's surface somewhere. And then the information part is not just the location, it's some kind of data that goes along with that location. In this example here on Google Maps, right, we have the name of the library that we're in, along with some other information like opening and closing hours, website, phone number, stuff like that. And then the system, right, is what you use to perform functions, to store the data, to do analyses. So usually when we talk about GIS software, it's normally software that you can upload data into, do all kinds of analyses and export. But if you don't think you have any experience using GIS, that might be untrue, because things like Google Maps, which I would imagine people use that or something similar quite often, for navigation or looking up restaurants or something like that, where, right, that is an example of a geographic information system. But today, right, we'll be focusing on software that allows us to bring in our own data, do analyses, and export our results. And why is GIS useful? Well, it allows us to solve geographic problems where location is either the answer or part of the answer. And then we usually use different layers to look at spatial relationships. And so this little figure here, right, we have our real world with its endless complexities. And then, we may be interested in a set of variables to help us answer our question. Well, we can take those spatial variables and display them two-dimensionally and layer them on top of each other to observe relationships and find locations. And so I think in this example, right, customers were thinking of it as like where should I open my business kind of question, and we're interested in land use, elevation, parcels, streets, and then ultimately customer location. So we're thinking about this kind of holistic picture involving multiple different variables that all are spatial in nature. And then with these kind of techniques, we can answer things like, where did the flooding occur, or where is flooding likely to occur? Why are cases of X disease clustered in a given area? Or like this example, where should I open my business? And then I'm not going to get too much into a lot of background about GIS. There are full classes on GIS and lots of information to go and delve deeper, but I'm really focused on sort of giving participants here the tools to just kind of get started with GIS workflows. But one of the pieces of background that I think is really important to think about off the bat is the data models, because that's going to inform how you think about what type of analyses you're going to do, and even what type of data you're going to look for, what type of file types you're going to look for right off the bat. So when we're talking about two-dimensional geospatial data, talking about two different types of data models, that's going to be vector and raster. You may be familiar with those in slightly different contexts if you do a lot of work with graphic design or something like that. But with GIS, vector data is going to be normally for discrete features. So points, lines, and polygons. Point features usually representing some kind of small spatial footprint discrete feature, like a stop sign or the location of a certain type of business, or a tree of a certain species. And then line features those are fairly easy to think about. I think like, rivers, roads, any kind of linear line features like power lines, things like that. And then polygon features used to represent boundaries and outlines of things. So you can think of like counties, states, countries. You also think of like lakes or geological features. And then on the other side, raster is pixel based, and those are normally best used to depict continuous features. So if we're thinking about elevation, right, which changes a lot, over a kind of local extent, we would normally depict that as a raster, where you can depict those as changes across space on the pixels. And then also things like aerial imagery, satellite imagery, those are depicted as raster data types. So when you sit down to do a GIS project and you're thinking about, okay, this is the research question that I need to answer, you can think about, okay, do I need vector or raster data? And then you start thinking about the file types and the analyses that go along with those file types and those data models. And on the software side, you have some choices with GIS, especially if you're doing specific utilization. There are a lot of different bespoke softwares for specific purposes, but we're talking about general GIS software and specifically general desktop-based GIS software. There's QGIS and ArcGIS Pro. So QGIS is we're going to focus on today. That's the open source. And then ArcGIS Pro is also a really great software. It's proprietary. I'll compare the two a little bit more on the next slide. But then you also have scripted processing and analysis. So Python and R both have lots of really great packages and libraries for working with geospatial data. Python is especially powerful for working with geospatial data because both QGIS and ArcGIS Pro are based on Python, and you can work with those two softwares within a Python environment. So yeah, QGIS versus ArcGIS Pro. ArcGIS Pro you may have heard of before if you're at all familiar with GIS. It's a great software, but it is proprietary. If you're affiliated with UT, you have an EID, you can log on to ArcGIS Online, download ArcGIS Pro. If you have a Windows machine to run it on, it doesn't run on Macs. But then, keep in mind that when you graduate, you will lose access to ArcGIS Pro. It is very popular and used a lot in the professional industry and public sector. So, I would encourage people to, while you have the chance to familiarize yourself with it. But QGIS, you're not going to lose access to it. When you graduate, it works on Windows, Mac, and Linux. And as I mentioned before, if we're thinking about reproducibility, QGIS is great because anyone can, download and use that software without paying an expensive fee to purchase a license. So if you're thinking about a broad audience, and especially if you have collaborators who may not have access to like ArcGIS Pro, QGIS is really, really valuable and can do pretty much all, if not more, than what you can do with ArcGIS Pro. And it's very customizable with plugins, and you can contribute your own code to the application. So here is just a simple Google trend result showing QGIS versus ArcGIS Pro to kind of show popularity amongst the two. And in the US, it is true that ArcGIS Pro may be a bit more popular, more widely used. But then if we take a global viewpoint, you see that QGIS is vastly more popular and more widely used if we're going by Google trend results across the world here. So if you want your research to be applicable to and reproducible for a large international audience and you want to have flexibilities with who you're collaborating with, then QGIS is a really, really useful software to have and be familiar with. All right, and then scripting-based GIS software, you can do geospatial analyses in both Python and R. The great thing about Python is, again, it both QGIS and ArcGIS Pro are based on Python, so there's a sort of long history there, but there's also a lot of great freestanding libraries and packages that work with geospatial data, and then you can plug into the kind of machine learning and automation stuff as well that Python is particularly good at, along with a wide range of other things that Python does well. Whereas R, you may work with geospatial data if you have developed workflows and use R to do like visualization and statistical analyses, like ggplot and all the really nice statistical packages that are within R. But today we're going to focus on QGIS and Python, and we will go through kind of base GIS workflow that's going to look like, okay, what does it mean to access and download GIS data across those two platforms? What does it look like to load and visualize the data? And then we'll perform some basic geoprocessing and analyses. And in seeing both, my hope is that you can be encouraged to have flexibility within your approach to GIS and have kind of a broader lens of what you can do and how you can even work across the two if you would like. So with that being said, we'll move into the demo. If you want to try to follow along, you're welcome to. With the coding, I am going to be typing out things line by line, so you might have a chance to keep up there. But I would say it may be difficult since I'm working across different softwares. So I would maybe encourage you to just sit and watch and take it in, and then know that the code as well as the slides and the recording will all be available later. But we will be working with a really cool data set, Buildings of Texas, which is hosted by our Alexander Architectural Archives here within the libraries. And then we provide that data set on the UT Libraries GeoData portal. And then along with that, we'll work with just a simple Texas counties layer and then use GIS techniques to make some modifications on those data to produce a map with only buildings in Travis County. So if there aren't any questions on the slide material, I'll go ahead and get started with the demo. Do we have any questions either in person or on Zoom? You can put something in the chat now. Yeah.
Like you mentioned that you were going to go over it later, and I don't know how much detail, but I'm just wondering what the difference between ArcGIS and the QGIS is in terms of functionality. It seems like from all that you've said, like personally, I'm totally sold, obviously, but like, why would anyone use ArcGIS if there isn't an obvious sort of functionality issue?
Yeah, that's a really good question. And I think there are a few reasons. So for those who may be on Zoom who didn't hear the question, it's kind of based on my description. Why would somebody choose to use ArcGIS Pro as opposed to QGIS? And ArcGIS Pro, part of it is just people are very used to using ArcGIS. Their software was very influential, especially in the US with the growth of GIS. So there's a lot of people who are just used to using that software is one. Another one is ArcGIS has done a really good job with producing ArcGIS Online that works kind of in conjunction with ArcGIS Pro and offers functionality for like story maps, doing kind of web-based mapping that's pretty accessible, things like that, and hosting kind of portals and making it really kind of easy and approachable to publish apps. So that's functionality, I think is why it still really retains a big footprint within industry and the public sector. But for most everything, there are open source options. So from all the kind of analyses that ArcGIS Pro has, QGIS has parallel functionalities. And then with that kind of, web mapping and stuff like that, with pretty much everything except for maybe hosting, large data sets and stuff, you can do it with open source software. Yeah, it's a nice question. Yeah.
Yes, you had on the slide that was like for Windows only. Do you know if there's like a reason for that, or it's like, because I remember using ArcGIS on like, I think it's like a website of some sort. So I'm wondering if like there's any way to kind of do it in the clouds or just like why not?
So some places might offer a virtual desktop option. So like if you have a Mac and have access to like virtual desktop, maybe a lab Windows machine, you could run it that way. The reason why it doesn't work for a Mac, I think, are just kind of deep-seated developmental dynamics that make it really hard to switch it over to Mac operating system, and long-standing relationship with Windows in terms of development. So yeah, there is a bit of flexibility there, but I would say if you have a Mac and want to do GIS, QGIS, it works very, very well on a Mac. And I think for me has always been a better option than like a remote desktop or like a parallel kind of approach to using ArcGIS.
Are we going to be installing QGIS if somebody wants to follow on, or should we already have it?
So it will be installed on the machines in front of you if you're in person. If you're online and already have it installed, I'd say and want to follow along, go for it. I think it would be hard to install it right now on the fly and be able to follow along. So I'd say if you have QGIS at your fingertips right now, feel free to open it up, but I think you'll also hopefully get a lot out of this if you just sit back and take in the information. All right, so I'll go ahead and open QGIS first. So here is what the interface looks like. And I just opened a new file when I logged on here. I'll open it from the beginning, so you can see what that looks like. What'd you say?
Where's prison? Or have you?
The city of this version.
Yeah, probably Europe somewhere. Yeah, in the back. Okay.
Yeah, I'm responding to it.
Oh, great, perfect. Yeah. All right, and then so this is what it'll look like when you open QGIS. If you've used it before, you'll have some recent projects that you will be able to choose from in here in this window. But to open a new project, you can just press this little blank white piece of paper there, and it opens up our interface. It's a pretty classic GIS interface in that we have our layers menu, and then we have our map interface here, which right now doesn't look like a map because we don't have any data. So we'll go ahead and fix that here. So the first data set I'll download is from our UT Libraries GeoData portal. There's a lot of really great data on here, from historical scanned maps to bespoke data sets like the one we'll be using today. And we also host some other institutions' data as well. And it's all publicly accessible and downloadable. So if you're unfamiliar with the GeoData portal, interested in geospatial data, definitely check it out. There's lots of really great stuff. But from here, you access this page, and to access this from the home page, you could search for it if you knew what you were looking for. You can also browse all. And then you can see our different providers on here. I'm going to specify our Texas hosted data sets, and then I'm going to sort by resource class. So this is where I want to work with a vector data set, and the way that this is laid out in terms of resource class on our website, that's going to be under this data sets category here. And now I can go ahead and download my buildings of Texas. By clicking on this link here, original shapefile, and you can see I get a preview of what that looks like here. So now that I have my data downloaded, and I'll actually, while I'm at it, I'll go ahead and download my Texas counties cartographic boundary map. So I access this by just Google searching, let's see, Texas county shapefile. So shapefile is the most common vector file type. So I know, okay, right, boundaries, polygons, vector data, and then file type, most common shapefile. You could also type like Texas County GIS data as well, could probably get you what you're looking for. And then I went down to this State of Texas Open Data Portal. I think you could probably find it on those other sites too. But that's what looking for GIS data oftentimes looks like, is you either have a reputable database that yet what kind of data sets are on there and access it, like the Texas Geodata Portal, or you can just kind of Google search and check out where you can find data by just doing something like Texas Counties shapefile or Texas Counties GIS data. And from here I can go to export, and I'm actually, for this one, for example's sake, I'm going to do the other common vector file type, which is GeoJSON. Notice there's some different options. Only some of these are actually spatial ready for GIS data. So if you download a CSV, it'll likely have location coordinates, but it won't actually be ready to use right off the bat in QGIS. So I'm going to do this GeoJSON and go ahead and download that. Now, if I go back to QGIS here, I should now see on my little browser pane here, I can access my computer and go to users. I'll have to allow it to access all these. And then in my downloads file, see those two data sets that I just downloaded are there. And if I click on these from this menu, they populate right into the QGIS. Now notice this is a shapefile. It will come with multiple file types within a shapefile. So there's the main shapefile file that's within those set of files. And then there are also kind of supporting files that you won't actually load into your map interface here, but they help to support the that main shapefile in terms of providing spatial information. So you have to keep them together in a folder, but then you just load the shapefile on there. GeoJSONs are just a single file. So that those are just kind of details to keep in mind when you're working with specifically vector data. So that's what it looks like to simply download and activate data sets within QGIS. And you can see I can start working with my map here. And importantly, I can also look at the underlying data sets. If I go to the layer menu, you can see that both of these are on here. So this UT architecture buildings of Texas layer is here, and then the counties layer is here. As we talked about in the slides earlier, using multiple layers to look at spatial relationships. Oftentimes ordering matters there. So if I wanted to order these differently, I can just drag them, right? And now my points of notable buildings throughout Texas are hidden behind the counties, but now they're in front. And I can also toggle these on and off as well. And if I want to see what the data actually looks like, I can open the attribute table here. And it opens up and I can see the information that I have to work with, right? Because it's not just location, it's also the information that comes with the location. And in this case, right, we have some addresses, we have the name of the building itself, we have some different kind of place IDs that help to connect this data set with others, and then we have the place type. So that is looking at the table here and the map interface. Let's close this out for now and do what we just did, but in Python. All right, so I'm going to start here just from a pretty much a blank Python template so you can see what it looks like to kind of organically start from scratch. This is a Google Colab based Python environment. So if you're unfamiliar, Google Colab runs Jupyter Notebook, which basically allows you to establish a virtual environment to run Python, which is useful for cases like this where we want everybody to be kind of working on the same environment and getting the same results and things like that. So I will share this code out after we're done here so that you can use it and work with it. What I do have started here, because I didn't want to go through and spend the time to write this all out while I'm up here talking, but this is a kind of an important part of starting a Python project. And I think one of maybe the more difficult hurdles to start working with Python is installing libraries and packages. And so in Python, right, if you either open it up in Colab or use it locally on your computer, either in command line or with something like VS Code, you will most oftentimes have to call in some packages and libraries that aren't just coming with Python. So that's what I'm doing here with these different actions. So you'll notice this pip with an exclamation point there, and I should probably zoom my screen in a bit for folks in the back.
2 questions.
Yeah.
I'm going to ask, will you share your Python code?
Yes, this will be shared along with the slides and the recording, all on the Data and Donuts library guide.
And there was a question from a minute ago about GeoJSON versus shapefiles and the differences, why you might choose one.
Yeah, so shapefile is the kind of longer established file type for vector data. So because it's been around longer and people are used to it, it tends to be more common still. But like I mentioned with shapefiles, they come with multiple files that are part of the shapefile itself. So you have your .shp file, that's kind of the main file you bring in ultimately to your GIS software. But then there are also these supporting files that come with it that help to kind of define different aspects of like the spatial projection and other things that we didn't have time to get through. So it's a little bit cumbersome because of that. They often come as zipped files that you'll download and then extracting them and loading them onto software. GeoJSONs, I think, are more efficient and likely, I think if you have the choice between using a shapefile and GeoJSON, I would usually choose a GeoJSON. It's a single file. It tends to be more efficient. It's a newer kind of improved file type to work with vectors. It's just they aren't as ubiquitous at this time because of the history of shapefiles. All right. Cool. Any other questions in the chat? We're good. All right. So this is, starting up Python. You'll see this pip here is an external command that I'll be calling. That's why I'm using this exclamation point here. That's just a special key that works in this case to call on pip, which stands for something like package installer for Python, I think is what pip stands for. And then you just write out install and then the libraries that you'll need to use. So I think the pip thing itself isn't that complicated, but it's kind of knowing, okay, what libraries and packages, and I just kind of use that interchangeably, libraries versus packages, which they both call on, you know, basically sets of code that allow you to do you know, functions within Python. So that's what I'm calling our different things here. When you're starting out with just a blank and you don't even know, okay, what you know, packages should I even call? Well, you could do a Google search like GIS, Python, packages, and yeah, you get some useful results here. Like you could look at this Reddit thread, you know, like a list of maybe some useful packages. So here, you know, I see ArcPy, which is if I want to work within ArcGIS, but from a Python environment. Here, GeoPandas is what we're going to be using. It's like a freestanding package that it builds on the general pandas package within Python, which is this really kind of large, ubiquitous data handling library. So here, GeoPandas builds on that. So, you know, you can do a little bit of background and research and figure out, okay, this is what I need to do. In reality, I oftentimes, you know, we'll start with just importing a few packages, and then as my code is kind of evolving and I go and I look at someone else's code, or I, you know, look at documentation, I figure out, oh, I also need to install this. So, you know, usually my code in practice doesn't have all of this right at the top. It's kind of strewn about as, you know, I call things that I need in a given cell and location. So that's something to keep in mind, is just thinking about, all right, what packages do I need to install? What ones I need to import? Yeah.
So sorry, I'm totally new. So the packages are things that are already stored in Python, or
So that they're written in Python, but don't come like native when you download Python or like access it on here. But you can install them in Python, and they basically just add functionality to the base Python, and introduce code that allow you to like run different functions. Yeah, and it'll make a bit more sense if you're brand new to Python as I kind of keep going, what's going on with these installing. And then we also import packages. So that's just calling packages that I already have installed. It's basically saying, I'm going to use this later, so I'm importing it. And then you will notice some of these have this as, and what I'm doing there is I'm shortening the name, because when I run a given function that's associated with one of these packages, that I need to provide the name. So if I'm going to be running, which I know GeoPandas I'm going to be running a lot, because that's kind of my fundamental baseline GIS package I'm going to be using. I'm shortening that because I'm going to be writing it a lot, and you'll see me write it going forward. So I have that shortened as there, and then these other ones where I do from and import, that's to kind of stay lightweight here, where maybe I'm not going to use a full large package, so I'm just importing like a specific functionality from that package to use later. So that's what all this stuff is. I'm going to run it here. If you are running code that you either are pretty confident or you know for sure is correct, and you're getting like X function is unrecognized, usually that means that you don't have some you know, package that's necessary to run that function installed. So that's one of the things you might want to check if you get an error message that's just like function not recognized, is do you have the right package installed? All right, but from there, I'll start coding here where I have those tools I know I need to use. It's, you know, basically like kind of putting together your toolbox or tool belt that you're going to need to use. And now that I have that compiled, I can go ahead and start running some functions. So, right, we downloaded data to run on QGIS. I could just go ahead and upload that if I was working locally on Python. I could just provide the path where that file is located and start working with it. For this example, I am going to directly use the URL to bring in the file. So what I'm doing here is I'm basically just naming a variable. So this is going to be my buildings of Texas layer that I'm bringing in. So BOT is my abbreviation for buildings of Texas. And now I'm going to call on my GeoPandas library here that I imported as GDP. So that's its name. And I'm going to call on that. I'm going to say GDP. I want to use GeoPandas. And, I could name that whatever I wanted. If I wanted to be, really short with it, I could just call it G and use that. But, it sometimes helps to use a few letters to make an abbreviation that you'll understand when you go back to your code. And then I can simply do this read file function. And a nice thing about this Google Colab environment is it starts to give me, as I type functions out, the name of the function, and then it gives me some of the parameters there that I can choose from. But if you're completely new to using a library, the place to start is the documentation. So I can go to GeoPandas documentation here on Google and say, I need to figure out how do I even load up my data sets. I can go to reading and writing files, and here I can see exactly read file. That's how I get started. And some literature here. We'll say now with large language models and being pretty intertwined with especially Google with Gemini, it'll oftentimes, when you start providing some like Python and code specific searches, like it'll just pop up code for you. I would say generally it takes a bit more time and reading to actually go to the documentation, but it's really nice later on to actually understand why your code is the way it is, which you'll get much more of if you read the documentation rather than just doing the AI code off the bat. But you will see that as you do Google searching for code and Python advice, that it does now tend to provide you oftentimes with direct code that you can use. But to directly call in the file here, and again, if we already had our data downloaded and available, we could just do copy and paste the path of that file in. But I can do directly from this shapefile, so not this URL that's at the top here, but the actual API endpoint that's accessible if I right-click on this link and say copy link address and fill this in here. Oh, and I made a mistake. That's live demoing. I need quotation marks here because this is a URL, so being treated as a string. And now I can run it. I didn't get any output because I'm just establishing a variable, but I did get that check mark, meaning it seems like it ran successfully. But I can now go ahead here and check this. And now if I wanted to say, well, how can I look at the map like I did in QGIS, making maps and plots, and go down here, I can see, oh, it's plot. So if I go to now plot.plot, and I can see my buildings of Texas layer in Python. So obviously off the bat doesn't look as nice as our layer when we loaded it into QGIS, but there are some things we can do, and I'll show you that. So I'm going to quickly now, and once I did one step, it gets easier for me to then go and do my other file, which I'll do the same thing. Whereas my Texas counties here. Sometimes places will have different systems for accessing this endpoint that you need. Here, right, I want to work with GeoJSON, and it provides me with the API endpoint here, which I'll copy. And I can just replace this, and I want to give it my variable a new name. So this one I'll just do TC for Texas counties. And now I should be able to run this, no problem. And I'll kind of stop consulting with the documentation too much to save time. But right, I'll want to now look at both layers together. Well, how do I do that? This is where it maybe gets a little more complicated, a little less familiar, but still not too bad. So to look at multiple layers in Python, I just establish a variable first that's going to be like essentially my base map, or the layer that I'm going to have as the base of my map. And I want that to be my Texas counties. So I'm defining that here. And now plot. And here, since I'm doing multiple layers, I may want to worry a little bit about what the layers actually look like so that they're compatible together. So I'm going to assign a color and some other visual definitions here. And you can see a list of different options that I have that's right in this environment, but I could also look at it on the documentation. So I'm going to define the color here as white, and then the edge color as black. And don't expect to know when you're using a new tool like this what you can put in these parentheses. And the parentheses here are basically what I'm inputting into this function. What arguments am I making? It's sometimes they're pretty logical and you can predict what some of the arguments are. Other times it doesn't make as much sense. So keep that in mind. And always, I would just say use the documentation to figure out what those arguments are that you can make. So for instance, like AX is kind of the main argument here to supply this base map. I wouldn't have guessed that on my own. And then I can define a marker type and then a marker size. And it doesn't, the live demos are nice because it's a realistic portrayal of what it's actually like coding, where you leave out quotations, equal signs. But here you go. So now I have two different layers on my Python map. And now we're at the same stage in both QGIS and Python. So I'll go back to QGIS to quickly run this analysis so that we can isolate just our notable buildings that occur in Travis County. There are a few different ways to do this. I'm going to do it, I think, there's a pretty approachable way here. So I'm going to open my attribute table again, and I'm going to find Travis County, which it's going to be under name. And as I would in Excel, I just activated this column and sorted alphabetically so I can easily go to Travis. I'm going to select that. You can see now I have that selected in my map. And if I right click on my layer here, I can go to export and save selected features as. So this is going to be really useful when you want to isolate certain things. And I can define, I'll just save it on my desktop, call this Travis, save, and add this to the map. So now you can see I have a layer that's only Travis County. And using that layer, I can now do what's called a clip, which is, I think, a tool that I use all the time. It's really useful in GIS where you just want to isolate points or features that occur within a given polygon. And I can find that here under vector. So again, knowing if you're using vector or raster is important because it even defines kind of the menus you're going to be using in QGIS. I'm going to go to clip. And here my input layer is going to be the buildings. And then my overlay layer is going to be Travis County because that's going to be the polygon containing those points. And here I can just create this as a temporary layer. If I was actually doing this as a project, I would probably actually save that feature. That's something to keep in mind with QGIS is oftentimes it likes to create temporary features. And if you're not careful, you can close your project and lose your temporary features. But so now I have my clipped features and I can see Travis County, what occurs in there. So a fairly simple little analysis here, but you can see just kind of what, clicking around in a GIS software looks like. Now I can fairly quickly, produce a new, or not really a new, but a derived data set for like a location of interest. And it would be very similar steps to like, define a certain type of building with this data set. So like, I only want to look at university buildings, for instance. Here in Python, we will do similar thing where I'm going to do some new code. Here, I'm going to start working with some brackets that are going to allow me to work with tabular data because so we are using GeoPandas, but ultimately, as we saw in those attribute tables we were looking at in QGIS, it's tabular data fundamentally. So to do that, we can isolate Travis here. So I'm going to name my new data set here, Travis. And then this gets a little bit confusing, but if you kind of think through it, it makes sense. So here I'm going to name my overall data set that I want to work within, which is TC. And now within TC, I want to select Travis County. So to do that, then I need to select, and you can see my choices here from the table automatically come up. I want to do it by name, but I missed a step here where I need to, again, define TC name. So I have this kind of interwoven brackets here in which it seems kind of oddly repetitive. But what's happening here is I'm saying, okay, I want to work within Texas counties. And then here to define name, I need to specify that it's also within Texas counties. I want to isolate this column because in theory, I could, kind of work within, multiple different sheets within, one data frame as an example. All right, so now I use this double equals sign. That's basically a way to say if it matches, then that's what we're looking for. As opposed to like a single equals sign, you use that to like assign variables and things like that. So I can just type out Travis is what I want to look for and run it. It seems to have worked, but again, to look at it, I could map it like I did earlier to make sure that I actually did what I wanted to. Another option is if I just type in Travis and do that, I can see the actual tabular data associated with it. And so I can see that looks like I successfully isolated Travis County. And so now I can take my buildings of Texas data set. I'm going to make a new variable called clipped and go back to my GeoPandas workflow where remember I named it GDP. So that's why there's GDP.clip is the specific function within GeoPandas that I'm going to work with. And now I'm going to define Buildings of Texas is going to be my input layer, right? Just like in QGIS, and then my overlay layer comes second, and that's going to be Travis. And notice here, so since these are variables, I don't need quotation marks. Whereas if I'm, like importing a URL or something that's just a string, I do need to use quotation marks. So since they're already established variables, I don't need to use quotation marks because they're objects rather than strings. And now I can see if that worked by plot. And look, cool, it worked. But at this point, you may be thinking, well, QGIS, it seems to be much better, right? Because I can kind of drag around and interact with the map. Well, you can do that in Python too. So, say I have this data set that I now want to work with in a way more akin to like QGIS, where I can drag and interact. Instead of plot, I just use explore. And this is a really nice function that comes with GeoPandas, where I can now zoom in and zoom out, and I can even hover over these data sets, and I can see the information associated with each data point. I could layer my two different data sets similarly if I wanted to look at counties and the buildings of Texas data sets together, but I think I'm running up on time here, so I might just end with this example. And I do want to make the point that, it seems like, okay, QGIS may be more approachable. I did it more quickly than, typing out everything and having to look at the documentation and figure out what are the arguments and inputs, which may be true as you're doing a new workflow. But, if I look here at my code that I have here, I now have everything I did laid out, which I can run again. I can put in different data sets and run the same workflow. Whereas in QGIS, I just have a final product and data sets. I don't have a record of, what were, the arguments that I put into the clipped function. I don't have details of the specific steps I took in the way that I do with Python. So that's, I would say, the real sort of advantage of Python is once you've done something, you have it as a record. You can run it again as much as you'd like. You can scale it up. You can run it with different data sets. And you basically already have your methods section written for you. You just have to translate it to the language for your manuscript or thesis. But then, there are obviously, some advantages with QGIS of, right off the bat, you have a nice way to explore with data. So, I would say if you're really interested in GIS, utilize as many kind of different softwares as you can, because they all have strengths. And it helps you to actually learn kind of the underlying things that you're doing rather than just a single software. And ultimately, if you're working with open source softwares, you have all the power over your methodology. You can look under the hood, you can make additions, you can help fix bugs. It opens you up to collaborate and ultimately make your research more reproducible, more collaborative in nature, and accessible to anyone, regardless of if they can access proprietary software or not. So that concludes my demo here, and 3 minutes over, but we still should have plenty of time for questions. So thanks all.
Thank you.
Yeah.
Can you say a little more about the Python thing there? So I see QGIS is like a system that has an inbuilt, if I understand correctly, like an inbuilt default projection of everything with like a map onto which it maps whatever data set you import. I'm not really sure what's happening in the Python thing. So the plot function is part of the GeoPandas, is it?
Yeah, but it also draws on like matplotlib, which is kind of the if you know R, it's kind of the ggplot equivalent. It's this kind of larger, not geospatial specific plotting library. So it kind of draws upon that and uses a lot of base and then just applies like geospatial data sets to it.
What, if it's not geographic per se, then that means the renders over here are basically like equirectangular or something?
Well, so you can see here the numbers on the axis will reflect the coordinate reference system that the data's in. So that's a really good question. And so for those on Zoom who didn't hear, we have a question about, well, how is Python handling the actual kind of background coordinate reference system projection of the geospatial data? So when you bring it in, just as you do in QGIS, with the file, there's a default coordinate reference system and sometimes a projection. So here,
Was the projection specified in the data set?
it's the same one. Yeah, so if I go here and go to bot and CRS, standing for coordinate reference system, I can see that information. So, right, this is a geographic coordinate reference system. This is the EPSG, which is an identifier. So it's just like a WGS 84. And
What's WGS for?
so that it's a really common geographic coordinate reference system. So it's not projected into like meters that you could use, and it just defines like, okay, the world geodetic system is what the WGS stands for. So this is the stuff that, if you took a GIS class, like an introduction to GIS class, spend about a week on basically taking three-dimensional globe and transforming it into a two-dimensional object, which, it takes math because you can't perfectly put it out on a flat sheet. So, and then from there, you can project the data into, some kind of unit that you want to work with. So if I were making really specific measurements here, I might want to project it into some projection that's based on meters or, something like that. So I could do some measurements.
So it's not part of the data. I'm kind of confused because
Yeah, you can change it, but it comes with a default.
With the data.
With the data,
I guess
yeah.
it's conceivable that you might have the same coordinates for each building in two different data sets, one of which is cylindrical and the other one of which is whatever, like Mercator, right?
Right.
Or would those be two different data sets?
I mean, I think it depends on maybe how you define a data set. You wouldn't want to use them in conjunction with each other, somehow. And, if you're in different units and take measurements, and depending on whatever kind of CRS or projection that you choose, you're going to have some kind of distortion. So you will get differences. So on that basis, yes, you can consider them two different data sets. But the underlying data, if they're the same kind of base, tabular data is going to be the same, but based on the differences in how they are projected, then you're going to have different distortions and you can get some different measurements. So that's why it is important to keep this in mind, especially I would say as you start making like measurements, or you need a high level of precision when you're thinking about a given location and identifying, say, like coordinates or something like that. Then you really need to think about this. For a lot of just basic GIS software now does a really good job of just kind of on the fly transforming data. So usually the way that QGIS tends to function is the underlying like project projection will match whatever like the first data set you bring into, and then other data sets you bring in, it'll just on the fly reproject those into that base projection that you have initially. Yeah, for sure. Thanks for the question. And yeah, for those brand new to GIS, which maybe a lot of that didn't make sense, that's something as you really work with data and worry about precision and the outcome of your analyses, you want to think about the specifics of the reference system and the projection that your data is in, because there are some distortions when you take a three-dimensional thing and turn it into a two-dimensional thing. Yeah.
GIS, like the last layer that you were in contrast on things so that I mean, how we do that.
Yeah, so the in QGIS you said? Yeah, okay. So yeah, from here, so we're working just with our Texas counties, and let me go ahead and clear my selection, which so I'm going to clear my selection. That's what this button does. And I'll go back in and I can go. So I'm right clicking on my layers menu here, and I'm opening the table that has all the different data points. And what I did was I just saw, okay, I have these, a lot of these different columns just have to do with either like spatial information that the software uses and you don't really have to worry about, or things like that can connect this to say, if you're working with like other census data with other states, see it has this like state identifier, that would allow you to kind of link it with Texas if you're working in multiple states and things like that. But here I can see pretty clearly, because I am familiar with names of Texas counties, that these names are associated with the different county names. And so I'm just going by this column here and finding Travis. And then as I would just in like Excel or, other tabular software, I'm selecting this whole row here to select the feature that I'm interested in, which in this case is Travis County, right? And so now the way that this is functioning, the table came up as full screen, and I'm just pressing escape to go back to my main interface here. And you can see when I selected that in the table, it selected it in my map here. And from there, this is a really, I think, an important step that can be kind of not obvious off the get-go when you use the software, is when you right click, you get this whole menu of stuff. And from here I can export, and I have different options. So if I just wanted to save this whole layer in another name in another place, I may just do save feature as. But since I've selected a feature I want to isolate, I just do save selected feature as, and then I name my file and save it. And then I should point out there are other ways to do that. So you can have a simple like little coded explanation to select. So if I went into my table here, I can select features using an expression. And so I could go in here and be like, name equals Travis, and select that way too, which, if you're doing something more complicated than just selecting a single feature, in a fairly small data set, then using an expression can be helpful. Yeah. All right. Well, if there aren't any other questions, and is there anything in the chat that I should answer? All right, great. Well, then thanks everyone for attending today. I don't know if there are leftover donuts or anything like that, but look for if you want to build upon this. All the materials will be available on the Data and Donuts library guide, along with the schedule for the remainder of the semester. There's some really good ranges of topics being covered, and it should be a really exciting series this semester. So and email me if you have any questions, or the materials aren't working for you, or whatever, and I'm happy to respond, but have a great rest of your Friday and a good weekend.
Thank you.
Okay.